Okay, let's dive right into this. Welcome to today's explainer. Look, if you're a university student sitting in a CS 101 lecture right now, feeling completely, utterly overwhelmed by early coding concepts, you are exactly where you need to be. Today, we're going to master the absolute foundation of computer science. We're talking about programming logic.
Let me guess. You've spent hours cramming Python or Java syntax, right? Just memorizing hundreds of commands for your midterms. But the second you open up a blank IDE screen at 2 a.m. to start that lab assignment, you just completely freeze up. It's an incredibly common pain point for early CS students. You've got all the commands floating around in your head, but putting them together into a working program, it feels absolutely impossible. I really want to validate that frustration right now. If you're struggling with this, your current study methods are probably failing you. But, and this is absolutely crucial, not because you aren't smart enough. It's because programming isn't actually about memorizing code.
Section 1. The blank screen struggle.
We've been taught to memorize things in school our whole lives, haven't we? But software development demands something entirely different. To understand why this happens, imagine someone asks you to build a house. You wouldn't immediately just start laying bricks, right? No way. You'd first understand the requirements, create a blueprint, plan out every single room, and figure out the materials. Well, programming works exactly the same way. Jumping straight into writing code without a plan is a guaranteed path to getting stuck. You're basically laying bricks without knowing what the house is actually supposed to look like.
Section 2. What exactly is programming logic?
So, if the blueprint is missing, how do we actually create one? Well, our solution, and honestly, this is the ultimate academic weapon for any CS 101 student, is programming logic. By definition, it's the ability to solve problems using clear, organized, and logical steps before writing code. It's that process of really thinking through a problem and determining the correct sequence of steps needed to solve it. Those programming languages you're stressing over, like JavaScript, Python, or C++, they're simply the tools used to implement this logical plan. If you don't have the logic down first, I promise you, knowing every single command in the book won't help you solve the problem.
Moving on to Section 3. Logic versus syntax. Beginners so often confuse these two completely different concepts. And separating them in your mind, that's the key to finally getting through those frustrating lab assignments. Look at the left side here. Logic focuses on thinking. It actually solves the problem, and crucially, it works in every single programming language. On the right side, we have syntax. Syntax just implements the solution, and the language rules completely change depending on whether you're using Java or Python. Mastering the logic is way more important. In fact, it's what makes switching to a new programming language incredibly easy later on in your academic career.
Section 4. Everyday logic in action.
Now, you might be sitting there thinking, you know what, I just don't have a logical programmer brain. But you actually already possess highly logical thinking. Just look at the systems you use on campus every single day without even realizing how logical they are. Take your standard student portal login system, right? Like when you're frantically trying to check your grades. How does it work? Well, step 1, you enter your username and password. Step 2, the system checks if the account actually exists. Step 3, it checks if the password matches. Step 4, you either get logged in or you get an incorrect password error. Notice something there? We literally just mapped out a software program using a series of logical gates, and we didn't need to know a single line of coding language to do it.
Or think about the vending machine outside your dorm room. You insert money. The machine then asks a logical question. Is the amount enough? If yes, it dispenses your energy drink and returns your change. If no, it displays insufficient balance. You've implicitly understood this logic since you were a kid buying snacks. See? You already think like a programmer.
Section 5. The 4 core logic skills.
All right, now that we know you have this capability, it's time to shift into the training phase. Because instead of just rereading your textbook over and over until your eyes glaze over, these are the exact skills you need to intentionally practice: problem analysis, breaking problems down, decision-making, and repetition. Problem analysis is really just understanding what needs to be solved and what info is available. But that second one, breaking problems down, that is the real secret. Taking a massive, intimidating problem and dividing it up into smaller, manageable tasks, that's exactly how real-world software is built. Imagine your professor tells you to build an entire online shopping system. Terrifying, right? But wait, first you just build a login, then a browse products page, then add to cart, then checkout, then payment, then the receipt. By breaking it down like that, a massive project suddenly becomes just 6 small, totally manageable tasks.
And as you build those tasks, you're going to use our third core skill, decision-making. Programs constantly need to make decisions.
Think about academic grading for a second. If score is greater than or equal to 75, then pass, else fail. That simple conditional statement is the beating heart of software logic. Once you can identify the decisions that need to be made, the code almost writes itself.
Section 6. Avoiding common beginner mistakes.
There are some exact traps you might be falling into right now that are making your lab assignments so incredibly frustrating. Writing code without understanding the problem, memorizing syntax, ignoring edge cases, and skipping the planning phase entirely. I really want to specifically call out that second bullet point. There's this massive myth out there that good programmers just memorize thousands of commands. The reality? Good programmers are just exceptional problem solvers. They don't memorize every single language rule, they just plan really, really well.
And what about ignoring edge cases? What happens if your program asks for an age and the user enters letters instead of numbers? Or what if they enter nothing at all? Anticipating the unexpected is a huge, crucial part of planning your logic, because if you don't plan for this logically, your whole application is going to crash the second your professor goes to test it, and nobody wants that.
Section 7. The ultimate test.
Okay, it's time to put all of this theory into practice and prove that you can solve a problem purely through logic way before you ever touch a keyboard. Here's your problem. Determine whether a person can vote. Think about the logic first. Step 1, input age. Step 2, we make a decision. Is the age greater than or equal to 18? If yes, display can vote. If no, display not eligible. Boom! We clearly and flawlessly solved the problem, and we didn't write a single line of actual code. The entire solution came purely from logical thinking. This leads us to a pretty profound realization. Professional programmers often spend more time thinking than typing. Let that completely reframe your approach to computer science right now. If you're stuck, step away from the keyboard. Just grab a piece of paper, draw out a flowchart, write out the plain English steps. Think first, type later. Develop your logic, and the code will become much, much easier. Look, programming languages are going to continue to evolve and change over time, but logical thinking, that will always be the bedrock of software development. So, as you head into your next assignment, I'm going to leave you with this question. If you can logically map out a vending machine or a voting system, what complex system will you easily break down next? Thanks so much for joining me on this explainer. Now get off your computer, go grab some paper, and start planning.